What's going on, cryptocurrency universe? It's the Bitcoin miner, guys. Well, I hope everybody's got their Chia farm going or planning their Chia farm. And today we're going to discuss the plotter. This is the plotter build that I've decided to go with. I believe it's the best balance for budget to performance and extended life. And what I mean is, I'm only going to fill up hard drives for so long. I'm only going to burn up my SSDs for so long. So I'm going to eventually switch it over to being a CPU miner, being a GPU miner, or, a kind of a life after plotting. Keep in mind what you're going to do with this. Whether it be even a gaming rig or whatever it is for your intended purposes. So you want to think about that. And in this video, we're going to discuss all of the different options, different ways of hooking up hard drives, different motherboards, different CPU choices, different RAM choices. Does it make a difference, and does it not make a difference? Stay tuned, guys.
Verus is a privacy-protecting protocol. People can't see your past transactions or balance when you use Verus, unless you want them to. The Verus community believes in privacy for all as a basic human right. Verus, the next evolution in cryptocurrency and beyond. Discover more at verus.io. Truth and privacy for all.
With any build or mining rig or mission in mind, we kind of start with the main thing, which would generally be the CPU. And in this case, I have chosen a Ryzen 9 3rd generation 3900 processor. This guy is 12 cores. It has 24 threads, and it's about $450 in the US. I know that price is going to vary in different locations. And that includes the CPU cooler, which actually works okay. I've been testing that compared to a liquid cooler that I have in the other rig. This is the liquid cooler I did put in another rig, which is the master liquid cooler. This is the second version. The first one kind of blew. Third version. The first one and second one kind of blew. This one does pretty decent. I can't knock it for $80, $85. It does work, and it works very well. So this is going to be your gaming rig. I would consider putting in a liquid cooler. But other than that, I'm not worried about it. It's like I've got two rigs side by side. The only difference is the cooling. Although it is in a server case like this with server fans drawing air across, which does help cool it probably more than a traditional case, especially if the traditional case does not have good airflow. So you may not have such good results with it. So you may want to consider a liquid cooler, but it's all going to depend on what case you're going to be using, how many fans are in the case, and what kind of airflow you are planning on. Because, we say plotting, but plotting is not, too much difference in mining. There's different parts of plotting, but there's parts of plotting that are similar to mining in the sense that it uses a lot of your CPU or all that you're willing to allocate to it. So, when you're plotting 14 in parallel, this guy is running full blast, 100%, 95% all day long, 24 hours a day. So you want to make sure that you've got your good VRMs on your motherboard, which we will discuss and get back to that here shortly. But, cooling is going to be a very important factor. So again, depending on your end use and what you guys are doing, you may want to consider spending $80 on this guy. It does work well. I will put all this links in the description for you guys, so that'll make it easy for you. So let's discuss CPU choices. You could go something with more cores and more threads. Each plot will use a minimum of 2 cores. you could use 1 core, but 2 cores is pretty much my ideal minimum. You could do 4 cores per plot. You can do 6 and you can do 8. 8 doesn't seem to be worth it unless you just really have it. 6 does seem to be worth it, especially 6 gigs of RAM. So, but there's a trick that you can over allocate and stagger start. So this is how we're able to do 14 plots and allocate 6 cores to each plot, is because we're staggering them out. So this is kind of a trick that we can do and get away with not such a powerful processor and still get a lot of plots done. Now, you're going to have a bottleneck somewhere. Rather the bottleneck be your RAM or the processor or your SSDs. So your SSDs, rather it be NVMe's, M.2s, or the server drive version, which we're going to cover all this stuff, so stay tuned, guys. But the choices that you're going to make is going to affect the way that this whole build is going to wind up working and what you're going to wind up being able to plot ultimately when you're trying to farm Chia. So, to me, this is good for 14. I don't think you can do more than 14 without drastically reducing speed. I'm getting really good times doing 14, like, 29,000 seconds, maybe. I think that's 8 hours, 8.5 hours, give or take. But that's 14 at a time, where this guy does do them, I think, at like 21,000 seconds, if you're only doing like 3 or 4 of them. I haven't tried just one. So, and the other thing is if you're going to do 14, 2 terabytes, which you need 4 terabytes in total of your temporary. Now, remember, this is temporary drive. You're going to want a cheap, whatever, 120 SSD, Kingston or whatever for your operating system. So now that we know that if you want to go over 14, we're going to need more than 4 terabytes, which is not a problem. You can go with 3. You could do RAID. And RAID, you're going to want to run this stuff in RAID as well. They'll run faster. But you could even go bigger. You could go 4 terabyte drives, 2 of them. You could go 2 8 terabyte drives, like we have in the Threadripper. So you're going to have a lot of options. But now you're also going to be bottlenecked by how much RAM you have. I like to allocate 6 gigs of RAM for more of a maximum speed. All the times I'm telling you is using 6 gigs of RAM. Where if you start reducing that to 4, your times are going to go up. You can actually do it with 2 gigs of RAM, but you're really going to be slow. And RAM timings are actually going to be very important. Now, I'm doing an AMD build because it's better for CPU mining later down the road versus Intel rig, and Intel winds up using more power, being 14 nanometers, where AMD is 7 nanometers, and we're looking for power efficiency, ultimately, as miners. So, these RAM modules, when you first plug them in, will automatically set at like 2200, 266 megahertz. And if you do not go in the BIOS and basically set it to 1600, you have to do this for every build, you will have really slow times. This could be a problem if you're trying to plot currently and you're just not seeming to get times like everybody else or able to do the amount in parallel. You should definitely check your RAM timings, and that's really easy. And go over here to speed, 3600. Now, AMD, this is going to be very important compared to Intel. You may not see such a drastic change on Intel versus AMD because of the hyper-threading. And it also depends on the chip you get, but the higher core counts are going to have multiple chiplets, and they are going to require hyper-threading. The lower memory megahertz, when it's running at like 266 or something, you're only going to be running at 1200 frequency for the hyper-threading. So not only are you getting the bump up in speed from the memory, but you'll also get the bump up in the processor's capabilities from the hyper-threading, which will go to 1800 megahertz. So again, memory is going to be very important in your build and something to not skimp out on. If you're going to want to do a 14 in parallel, you're going to need pretty much every bit of 32 gigs of RAM. So you're really going to have to, I guess I like to keep it even. Just go ahead and get 64 so that I can do more later on, especially with Verus mining. But if you're fine with doing 13 in parallel, and don't want to spend the extra money, just get 32 gigs of RAM. And you can run 6. Now, that's talking about 6 per plot, which is at the higher speed. You could always kind of still do 14 at 5, or you got to leave some for the main operating system. You don't want to bottleneck that up. So there's a few different combinations you can do without having to spend the $400. Each module or each kit every 32 gigs, each kit is going to be about $200. I think it was $190. So, it's kind of a personal preference on, again, what your end use is going to be. And, again, you can just get away with 32 by going with 5, and it'll be a little slower than 6. So, there you go, guys. There's your RAM options and choices. So, let's go ahead and take a look at the motherboard and what you're going to want to look at for a motherboard. I went ahead and chose the Tough Gaming Board. It's actually a really good choice, especially for mining. It meets a lot of military specs. It's kind of designed to be abused a little bit. Plus, it actually meets a lot of the specifications I was looking for, especially a good price point, which was about $180 without Wi-Fi. Just depends if you can get it in stock or how fast you're going to get it. Wi-Fi is about $20 more, so that's kind of a choice if you want to spend the extra money for the Wi-Fi on the board. But the VRMs on this board is actually really good for overclocking, so that's something to very much keep in mind. Does it have 12, 14, or 8? It's going to really matter, especially when you're running something 24 hours a day, full blast. So this was my board of choice. And the other thing is I'd like to point out, when you're also thinking about boards, this doesn't affect me, but these are the slots you have. So because I'm using a server case, I can easily just use a riser card and put a graphics card back up over in here, where the motherboard will be over at the other end. But in a traditional case, you kind of have to use a riser card like this rig here and sit the GPU up vertical. There's a few different options and a few different ways that you can achieve that, so that you can run both of your high speed. Well, it depends how you connect it. We're going to cover that too. SSDs. So these are my personal choices. They have a higher endurance, and you're going to be able to do more in parallel. I keep saying 14 in parallel, and that is using the commercial drives. Using standard NVMEs, they are slower slightly, but that you can only do 12 in parallel. It just starts to bottleneck. It gets very slow once you start getting over 12 in parallel. Even really 10, 12 is really pushing these for some reason. Plus, the read and write delays are much greater on this. These drives are just so much better for the price points. These guys are 350, 380, where these are like 450. You can get them used on eBay. It depends, it's your choice. I'm just trying to cover all the options. But you're also going to have to buy one of these cards for the Intel server drives, which are about $40. Now, why we're talking about this is your board choices is you're going to need to If you want to run 2 of them, and again, run RAID, you're going to need to run 2 of these different cards, which are the 4X. So you have to use your main slot. Now remember, your top slot here always has the most bandwidth. Your next major slot like this will have less bandwidth. As you can see, it's kind of got, kind of little metal around it. It's a little nicer looking, where the other one is not as nice looking. That's because it's kind of illustrating to you that this is the main slot. So you don't want to run your graphics card here. You do want to run your primary. It depends on your rig purpose, but for this rig, we're going to run our primary SSD in that slot. And of course, the next SSD in the other slot here. Now, you cannot use those drives in this slot. Now, if you're going to use the M.2s, this board has 2 M.2s, one here and one here. Most boards have 2. Higher-end boards may even have some in the back or more than 2. But the problem is usually only one of them is Gen 4. You do not want to use Gen 3. The endurance ratings are generally lower unless you're just getting 1 or 2 very particular versions. So you'll burn those up very fast versus a Gen 4. Gen 4 has a decent life expectancy, maybe 3 months, versus a Gen 3, we're talking like 30 days doing plotting 14 in parallel. You will eat this drive up in about 60 to 90 days, plotting 14. Well, you can't do 14, so probably a little bit longer in parallel, where this one will last at least probably 6 months, give or take. 90 to 6, 3 months to 6 months. It's going to drastically alter, but I noticed it dropping 1% every 5 days. Haven't really done the math, but that's kind of a rough estimate. So when you're looking at boards, these are things to consider, and where you're going, which drives you're choosing, and that both M.2 options are Gen 4s. This board does have that. If you're not using M.2 and you're going to go with the server drives, then where and how you're going to plug them in, and also plugging in your graphics card. Every board is going to have different options, and these are things that you're going to want to be aware of as you are choosing your parts and as you are building your rig. Now, there is another way to hook up the U.2 drives, and that's actually through the M.2 ports. So instead of buying this adapter, you can buy another adapter, which is the M.2 adapter. It's a cable. You're going to have to power it, and it's a bit more chunkier. You're going to have to put it somewhere. So there are other options. You could mount a graphics card in this if you want to use it as a gaming rig, and you maybe use this slot and this slot to run your two temporary SSDs. I know there's a lot being covered here, guys. Please ask any questions in the comments, and hopefully other people will help. I don't know how available I will be, but I'll do my best. So this really covers your board. And this is primarily thinking, by the way, USB hub style. Otherwise, you're going to want to pay close attention to your SATA ports. This one only has 8. So without an expansion card, you can run 8. Some higher end drives, you can run 10, 12s, motherboards, 10, 12 hard drives without having to run a expansion board. Okay, let's go ahead and discuss the power supply. You do not need a 1600 by any means. It's just what I happen to have around. You could easily use this. I wouldn't go anything smaller than a 650, but a 650 Gold series, just really any 650 Gold would be just fine. Depending on the graphics card you're going to run, if you're going to, run a 480 or... Anyways, a 650 will probably give you about 150 watts or so on a graphics card is what I'm thinking. If you're going to want to pull more or run a bigger card, I would definitely go with something like 800. Just you always want to leave a 20% headroom of your maximum draw. So just keep that in mind when you guys are also choosing a power supply. Now, case, I'm obviously going with a custom case. It's what I have. These are, custom components that I have over here. It's already got the preset stands, but I will need to add a couple in. I have to use a GPU extender cable so that I can run it from one end of the box to the other, and a custom fan cable to run the fans. But again, for you guys, it's going to be just easier to build the case that I showed earlier. I can put a link in the description for it. It's really cheap, $40, and it works great. This cooler I showed you earlier works for that. Pretty much all these parts work in it. I just built that version and then decided there's no point in buying cases. Just use my server cases. All right. Let's also now briefly talk about external hard drives and where you're going to store all of these plots. You can do internal, and you guys are going to want to definitely check out my hard drive video. It should be out before this one, discussing about different hard drives, where and what you are going to want to use. I like the external. They're a lot cheaper than internal, and technically it's the exact same drives. You can do the work and chuck them. You can open up these external drives and pull the hard drives out of them, and then just use them in a normal enclosure like you would normally think of using. Let's discuss the operating system. Once you do a build one time, you could use something like this, which is a hard drive or an operating system copier. I can also put a link for that. There's a whole video on that I put out several years ago. But I just copy the build and kind of make some changes to it and set up each individual system. This is the USB hub that I use for the setup. I use 2 of these per computer. I'm using a Windows setup, so I can run 23 per bay, and I have 3 bays planned with 1 utility bay, which I'll put a monitor and have all this set up. And this will be my Chia farming location, so I should be able to do all of this in theory on standby. Each drive will pull about 5 watts, give or take. So I'm thinking around 500-600 watts. Startup could peak at around 1200 watts. But yeah, 500 watts to run maybe a petahash if I ever get that high. I'm going to have to sell some Chia. Hopefully that'll be happening soon and we get some good prices for that. But I want to teach everybody what and how to get started and how to go and how to build your Chia farm. So, happy farming. I think I've actually covered everything but your power strip. If you are going to use the external drives, pay close attention to your power strips, because sometimes they go this way or this way. And you want to make sure that you have enough room so that you can use the correct power strips. And the power plugs that is going to work best for the situation that you guys are building. And again, happy Chia farming, and thanks again, guys. Make sure to like, subscribe, and talk to you soon.
There are a lot of payment methods available, and they all address privacy differently. If you go to a store and purchase something with cash, you don't have to tell the cashier how much money you have or purchases you made in the past. But in today's digital world, you can't use cash. So what do? You can use a credit card, which can do a lot of things that cash can't, like sending international payments or purchasing things online. But credit card transactions aren't private. Your name, address, purchase history, and balance info are stored by merchants and credit card issuers. This gives them access to information like how much credit you have, your traveling history, as well as things you buy. and they can reduce your credit or even worse, cancel your card altogether, leaving you without a source of funds. Another possible solution is cryptocurrency like Bitcoin, one of the most popular, but it's not private. Financial transactions using Bitcoin are stored in a public blockchain, which is transparent to everyone, not just the payment processors or merchants. Anyone can see the balance in all transactions of any Bitcoin address. Now there is a new way to combine the privacy of cash with the global reach of crypto. It's called Verus. While Verus provides transparent addresses called T addresses as well as transactions very similar to Bitcoin and visibility on the blockchain, Verus users also have a choice to send and receive funds and encrypted messages using the latest cryptographic technology known as ZK snarks, by using a fully private Verus address known as a Z address. T and Z addresses are like HTTP and HTTPS. HTTP is the underlying protocol that lets you browse the web. In the early days of the internet, hackers could capture sensitive data easily because the original HTTP protocol wasn't encrypted. This eventually changed, and people realized the need for encryption, and a new standard was born, HTTPS, which is what most websites use today. HTTPS is a secure version of HTTP. It keeps information private that is sent over the internet. Verus is a privacy-protecting protocol. People can't see your past transactions or balance when you use Verus, unless you want them to. The Verus community believes in privacy for all as a basic human right. Verus, the next evolution in cryptocurrency and beyond. Discover more at verus.io. Truth and privacy for all.